Alright, so we're starting chapter 2. We're going to start off with a little review. You guys have seen complex numbers before, but we're going to talk about them and make sure that everybody's up to speed on them. So first things first, the imaginary unit I is what actually gives us complex numbers. The imaginary unit I is defined as the square root of -1. Therefore, if we square I, we're going to get -1. So anytime you have I squared, that's going to be a -1. You can actually also go through and say I cubed. You can think of it as I squared times I, which gives you -I, and I to the fourth as I squared times I squared, which is -1 times -1, which gives you +1. So I to the fourth is actually +1. And you can use that to actually break down really big powers of I if you actually need to. Now, complex numbers and imaginary numbers are the set of all numbers in the form a plus bi, with real numbers a, that's the real part, and b is the coefficient of the imaginary part, and I is the imaginary unit. Okay, the real number a is called the real part, and the real number b is called the imaginary part of the complex number a plus bi. If b does not equal 0, then the complex number is called an imaginary number. An imaginary number in the form bi is called a pure imaginary number because there's no real part attached to it. And of course, if b does equal 0, then it's just a real number. You don't have any imaginary part at all. So our complex numbers can be broken down into two different parts. Real numbers with a plus bi, with b equaling 0, that gives us the real numbers, and imaginary numbers, if b does not equal 0, of a plus bi. Now, as we just talked, the imaginary numbers will also include the pure imaginaries where a equals 0, and all you have is an imaginary part. So here we have -4 plus 6i. A, the real part, is -4. The imaginary part is 6, or 6i. Here, if we have 2i, the real part is 0, so 2i is a pure imaginary. And b, the imaginary part, is 2, or 2i. Now if we have 3, that's 3 plus 0i, so the imaginary part is 0, therefore this is a true real number, or just a real number. It's not complex and it's not imaginary. So the real part is 3. Now there is a rule for the equity of complex numbers. It says a plus bi is equal to c plus di if and only if a equals c and b equals d. For two complex numbers to be equal to each other, the real parts must be equal and the imaginary parts must be equal. Not or, but and. Both parts have to be true. A would have to equal c and b would have to equal d for these two complex numbers to be equal. Alright, so let's express this as a multiple of I. Well, with -16, what you want to do is you want to actually split this up into the -1 times 16. Now, I'm going to show you the whole work, but you can actually do this part in your head. But you're going to now split it up into the square root of -1 times the square root of 16. So, of course, the square root of -1 by definition is I, and the square root of 16 is 4, so we end up with 4i. Now, if we do the 7 times I, quantity squared, and we're going to square both parts here, we're going to end up with 49i squared. But what do we know about I squared? By definition, if the square root of -1 is I, then I squared is going to be -1. So this is 49 times -1, which is -49. All right, now we can also do operations with complex numbers, and we're going to start looking at some of those right now. You can add and subtract complex numbers, and all you're going to do is add the real parts and add the imaginary parts. The coefficients of the imaginary parts are going to be what's added. Be careful and don't say that I plus I gives you I squared. That's not true. And I plus I is not actually being added. That would give you 2I. What's being added is BI plus DI. So you're adding those coefficients, and that's what's going to give you the new coefficient for I when you're adding. Well, same thing with subtracting. Very carefully, be aware. This is the thing I've been harping on for a while. Make sure you put that second thing that you're subtracting in parentheses like we have here. That way you're going to remember to A, either distribute the negative through if you're going to take an extra step, or it's going to help you to remember to subtract everything in this second part. So I'm going to do A minus C and B minus D. Don't forget the minus. The parentheses are going to make it less likely that you're going to forget that subtraction with all the parts of the second part. So you're going to do it exactly the same way as you did up here in real part minus real part, coefficient of imaginary minus coefficient of imaginary. All right, down here at the bottom there's an example. We've got 5 minus 11i plus 7 plus 4i. Since we've got the plus, we can just remove the parentheses. There's no change to this, and we're going to have 5 plus 7 gives us 12, and I'm skipping a couple steps here, you can see, because you guys are smart enough you can do this. Just understand what you're doing. Negative 11 plus 4 times I is going to give negative 11 plus 4 is going to give me negative 7 times I. Now, if you need to break it up, go ahead and do that. All they did was they moved the real parts over here together and then grouped them. And then they moved all the imaginary parts over here together and then grouped the coefficients and did the operations. All right, so let's perform the indicated operations here. With this one, we've got 7 plus 4i minus 9 minus 5i. I'm going to go ahead and distribute my negative as I'm removing my parentheses. So the first one's going to stay the same, 7 plus 4i, and then minus 9, and negative times the negative 5i will give me plus 5i. So we have 7 minus 9 is negative 2, and 4 plus 5 gives me plus 9 times I. So there's my answer. All right, with the second one, since I'm just adding, I don't have to worry about distributing. You can go ahead and think about it distributing. Distributing a positive 1 all the way through doesn't change anything. So you get 8 plus 3i plus 17 minus 7i. So 8 plus 17 will give you 25. And 3i minus 7i gives you minus 4i. All right, now multiplication of complex numbers is performed in the same way as we multiply polynomials, using the distributive property and the FOIL method depending on what we're doing. If we're doing a binomial times a binomial, we're going to do the FOIL method. The distributive property would be if we had something like where we just had the 3i. We would distribute that through to each part and multiply and simplify as we get to it. So here's an example that we're looking at. It's like 7 minus 3i times negative 2 minus 5i. Notice we have no operation here. We just have the parentheses crammed together. Be careful. Make sure you're doing the right operation for what you're doing. So we've got FOIL first. 7 times negative 2 gives me negative 14. First outer is going to give me 7 times negative 5i gives me negative 35i. Inside is going to give me negative 3i times negative 2i, which gives me plus 6i. And then last, negative 3i times negative 5i. It's going to give me 15i squared. Well, don't forget, I squared is negative 1. Notice they simplify that. Guys, you should never have, if you simplify a complex number, for it to be simplified completely, you should never have I to any power other than 1. If you have an I squared, an I cubed, an I to the 4th, an I to the 23rd, you have not simplified that thing completely. You have to get it down. At the most, there's going to be 1. But anytime you have the multiple powers, you need to simplify them down. So we got negative 14 minus 35i plus 6i minus 15 when we do that multiplication here. And then they group them together, but you could do negative 14 minus 15 gives you negative 29. Negative 35 plus 6 gives you negative 29i. Alright, so let's do one of these. So we've got 3 minus 5i times 6 minus 2i. So first, 18, outer, negative 6i, inner, negative 30i, and then last, plus 5i times 2i. I'm plus because negative times a negative, and that's going to give me 10i squared. Now remember, the I squared is negative 1, so that's going to become a negative 10. So 18 minus 6i minus 30i minus 10. So 18 minus 10 gives me 8. Negative 6i minus 30 more I gives me minus 36i. Alright, now also we're going to have to do some division. Now division, in all honesty, is, well, it's not looking really like anything we have of division. And we're going to have to use conjugates for that. We'll talk about those right now. Conjugate of a complex number, a plus bi, is a minus bi. All you're doing is you're changing the sign of the imaginary term. So you're changing the sign only of the imaginary part. And you'll see why we're going to do that in just a second. Actually, you can see it right here because your middle terms are going to cancel out. And that's going to leave you with just a real part and just a real part. Remember, the b times negative b, the bi times bi is going to give you b squared, and I squared is a negative 1, so that's why this changes to a plus. So same thing with these. But anyway, a and b are both going to end up being positive numbers, or sorry, real numbers, so that your imaginary part goes away. And you can see that in this example down here where they actually show you every step all the way through. So the multiplication of complex conjugates gives us a real number, and that's it. Now, you can't just randomly multiply by the conjugate of a complex number to get nothing but reals. You actually have to multiply it much like we do with fractions and things like that. And that's primarily where we're going to use this. So using complex conjugates to divide complex numbers, we're going to divide and express the result in standard form of 7 plus 4i over 2 minus 5i. We want to get rid of the complex number on the bottom. That's really all you're going to end up doing when you end up dividing. So we're going to take that and we're going to multiply top and bottom by the conjugate of the bottom. Remember, you have to multiply both top and bottom because that has a value of 1. You're not changing what this thing's value is, you're just going to change what it looks like. So you're going to have to FOIL it out on top, and you're going to get this, and you're going to have to FOIL it out on bottom, but the shortcut is you're going to get 2 squared plus 5 squared. Well, 4 plus 25 gives you 29. And we simplify everything on the top, and you're going to get negative 6 plus 43i over 29. And then what you're going to do here is you're going to take that 29 and you're going to divide it into both terms on top. So we get negative 6 over 29 as my real part. Remember, you're getting it in the form a plus bi, not a plus bi over some number. So this is the form you want it in. You're going to want to make fractions out of both of these, and that's in standard form for a complex number. So negative 6 over 29 plus 43 over 29i. So make sure you put your final answers for these division problems in that form. Alright, so let's do this one. So we've got 7 plus 6i over 5 minus 9i, and we're going to divide this, which means we're going to multiply by the conjugate of the bottom. It's going to be 5 plus 9i, top and bottom. Once again, because that has a value of 1, and anything times 1 is itself. Now, when we multiply across the bottom here, we're going to end up with 5 squared plus 9 squared. And on top, we're actually going to have to FOIL this out. We're going to have 35 plus 63i plus 30i plus 54i squared. Now when we go to simplify, on the bottom we're going to have 25 plus 81. 25 plus 81 is going to give us 106. And on top, simplifying, we know the I squared is negative 1, so this is minus 54. So 35 minus 54 is going to give us negative, what, 19? And then 63i plus 30i gives us plus 93i. Now, we're not done here because this is not in standard form. Remember, you've got to divide that 106 into both parts. So in standard form, this is negative 19 over 106 plus 93 over 106i. All right, so let's try this one again. Let's try another one of these. So we're going to multiply by the conjugate of the bottom. We've got 4 plus 5i over 4 plus 5i. And on the bottom, 4 times 4 gives us 16. The insides are going to cancel out because of the plus and minus, and then we have negative 25i squared, which makes us plus 25. And then on top, we've got 2 times 4, which is 8. 2 times 5i plus 10i. 3i times 4 gives us plus 12i. And then 3i plus 5i gives us plus 15i squared, which with the I squared becomes minus 15. I don't know why I wrote 16. And then when we go to simplify, we've got 8 minus 15, negative 7. And 10i plus 12i plus 22i over 16 plus 25, which is 41. And then we just divide that into both parts just to get it in standard form. So negative 7 over 41 plus 22 over 41i. Now, when we take the roots of negative numbers, we need to deal with the negative first. The principal square root of a negative number for any positive real number b, for any real positive number b, the principal square root of the negative number negative b is defined by I times the square root of b. And that is the principal, also known as the positive square root. So if we have the square root of negative b, we're looking, and there's no plus or minus out here in front or no minus out in front, we're looking for the principal or the positive square root of that number. That's the same case with any of the problems we look at The only time that you do the plus or minus is when you introduce the square root in the process of solving it. So if you take the square root, it's not part of the actual problem, then that's where you put the plus or minus in. Now, because the product rule for radicals only applies to real numbers, multiplying radicands is incorrect. When performing operations with square roots of negative numbers, begin by expressing all square roots in terms of I. Then perform the indicated operation. Now, what all that just says is this. If you have the square root of negative 4 times the square root of negative 16, this is not equal to the square root of positive 64. It's not equal. Do not do the multiplication there. Because the product rule for radicals only applies to real numbers, these are not real numbers. So you have to get those into the real numbers first. All right, so what would you do with this? Well, that's simple. You would take the negative, treat this as negative 1 times 4 like we did before, and bring the I out front. So I times the square root of 4 times, same thing here, negative 1 times 16, and bring the square root of the I out, or the square root of negative 1 out. Now we can actually multiply our radicals. So we could do 64I squared. Now, or you could have gone ahead and simplified this and found that to be 2I times 4I, and what happens there? We end up with 8I squared, which is negative 64. Now notice the big, no, that's not right, negative 8, sorry. So notice the difference here. If you just multiplied these, you would have got the square root of 64, which is positive 8. Well, here we end up, when we do it the correct way, we end up with negative 8. So be careful. Take the I out before you go multiplying square roots. Take the negative out of the radical before you start multiplying square roots. So there's an incorrect example. That's actually going to be negative 10. Because you've got an I with this one, an I with that one. You'll end up with I squared times the square root of 100, and that's going to be negative 1 times 10, which is negative 10. There you go. All right, so let's perform the indicated operations and write the result in standard form. So negative 54 minus 7 times the square root of 24. So we're going to need to reduce these to see if we can actually combine them together, and we're also going to have to take out the i's. So let's go ahead and break this 54 up. We're going to have the negative 1, of course. Is there a perfect square that's a factor of 54? Well, yeah, there's 9. And that's going to be leaving 6 inside. All right, and over here with the 24, same thing, negative 1. Is there a factor of 24 that's a perfect square? Yes, 4. So that's going to leave me 4 times 6. Now, everything that's a perfect square can come outside. So I've got the square root of negative 1, I. The square root of 9, 3. So I've got 3I times the square root of what's left inside, just the 6. And over here with this one, i's coming out and 2's coming out. So minus 14I square roots of 6. All right, now once again, our radicals are the same, so we can actually combine these. So we've got 3I minus 14I, so that's going to give us negative 11I times the square root of 6. Now that's the imaginary part, and if we wanted to put this in standard form, we would need to have a 0 out here just to measure or show the real part. Now, would it be counted off if the 0 was not there? No, it would not. All right, so let's do this one if we're going to square this thing, with a problem like this, guys, it's a lot easier to just go ahead and write it out, because you do have to FOIL it. A lot of people will forget this. And they'll just try to square the first and square the second. This will keep you from doing that. Now also, before we do any multiplication, we need to deal with this negative that's in this radical. Remember, we're not going to be able to multiply negative square root of 7, or square root of negative 7 times the square root of negative 7. We've got to pull that I out front. So let's go ahead and do that. We're going to have 4 plus I square roots of 7 times 4 plus I square roots of 7. Now we can do our FOILing. So 16 plus 4I square roots of 7 plus 4I square roots of 7, and then plus plus gives me a plus. We're going to have I times I, so I squared, and then square root of 7 times the square root of 7 is going to give me the square root of 49, which is 7. Alright, so when we go to simplify, let's go ahead and write everything out. Simplify each term as much as possible. 4I square root of 7 plus 4I square root of 7 plus the negative 1 is going to make this a negative, so negative 7 becomes a minus 7. 16 minus 7 is 9 for the real part. 4I square root of 7 plus 4I square root of 7 gives me plus 8I square root of 7. So there's my answer. Alright, you guys try this one really quick, and I'm going to show you the answer in just a second. I'll show you the answer, pause the video, try to work it out, and then I'm going to show you the answer for you to check it in 3, 2, 1. Alright, so here's the answer. You can divide the 4 into both parts here, and you're going to be able to simplify this a little bit. The negative 1, 16, and 3. The 16 and the negative 1 gives you the 4I out in front of the radical. You still have the 4 to divide into that, so these 4's are going to cancel out. Now, then you're going to get negative 2 plus I times the square root of 3. Now, you also may have seen or done this somewhere along the way. And then in this case, guys, remember that it has to divide into both parts up here to work. Here I've already divided it separately.